It's now my pleasure to introduce Trevor Lundy. He's with GLY. He is an integrated design engineer and a lead GA. He's here to present on virtual design and construction and what this technology is doing into the industry and impacting that, and what that means for how we train our workers to be prepared for this.
So, we're going to talk a little bit about technologies and processes of VDC. VDC is Virtual Design and Construction. I'm sure maybe many of you have heard about BIM, which is Building Information Modeling, and essentially everyone has gotten sick of hearing about BIM, so they came up with a new one called VDC. That should probably be with us for another couple more years. So, as Shana mentioned, I work with GLY Construction. This is just a little bit about us. We work primarily in a private negotiated world. We're up to about 500 employees now. That's office and field, and that's about as high as we get with kind of the upturn right now. And the majority of the markets that I work in are dedicated bioscience labs, technology labs, and healthcare. And really my role is to help coordinate a lot of high-rise steel and concrete design. A little bit about me. Born and raised here, came out of high school and went directly to the University of Washington. Was there, kind of found good direction, liked what I was doing, but the UW just really wasn't my deal. And so I guess you would call it I dropped out. And of course my parents were really excited about that. So my mom brought to me a couple of pamphlets about Lake Washington Technical College and said, you know, if you're not going to go to college, you need to do something and you need to have a focus with it. So I ended up over there in their architectural drafting program, really enjoyed it, got through it, and ended up over at Montana State where I pursued architecture. So my education and the majority of my professional background is in commercial architecture. I now work with GLY Construction. At the architecture firm, I found myself in a place where I managed a lot of the construction projects. And through that kind of interaction, found that really the contracting side was really kind of where I fit in, just me personally. So at GLY, I am what you call an integrated design engineer, which essentially just means that I'm a bit of a liaison between the construction, the crews out in the field actually doing the work, the contracting team in the office, and then also more so the design teams, given my background. So in today's world, we're putting shovels into the ground before design documents have even become complete. So the contractor's role in assisting to the design early on and keeping things moving is becoming more and more prevalent. So VDC, Virtual Design and Construction. What is the conversation surrounding that? What we see is a lot of talk about Revit. Is everyone aware of what Revit is or heard that at some point in time? You know, AutoCAD is, well, here, let's back up. So Autodesk, they're one of like the 3 largest software manufacturers in the world. They essentially create all of the creative and design and construction related software across the world. So AutoCAD was their main platform that produced everything in 2 dimensions. And then about 10 years ago, Revit started to become really prevalent in the workplace. And that just put us into a 3D world. And when we're working in 3D, we're able to kind of get more of an idea of what realistically we're working with in terms of coordination. And of course, that brings multiple parties into one kind of collaborative environment since we're able to look at so many different aspects. So is Revit part of the conversation of this idea surrounding VDC? And my answer would be absolutely not. Revit is a tool. And I've never once come across a tool that helped me develop a goal or help me develop a process to meet that goal or to end up at an end result. So you're going to start to see a theme develop here. Revit to me is a tool. It's not really a process. Is the conversation about modeling? Again, I would say no. Modeling is all about being a tool. The model itself is a tool. It's not a process. It doesn't really get us to an end result. Of course, the big argument there is, well, if we're working in a virtual world and the model essentially is that virtual piece, then obviously it's a very important part of the process, but again, it's just a tool. Okay, BIM. BIM stands for Building Information Modeling. At the very beginning, this was a great concept, and still is. The idea that you have a model of a building, and that model and all the components and pieces of that model contains information. And that's actually very, very powerful. The problem is that the programs don't just give you the information to the model on their own. That information is actually input by people, and then it's only valuable if you're actually extracting it in a manner that gives value to something that you're trying to figure out. So I would say 9 out of 10 times, really the information part of the model is missing. So the idea of BIM is great, don't really see it in practice. In technology, well, I would say technology isn't really a process, it's not necessarily a tool, but it's that driving factor that's telling us, hey, there's a better way to do what you're doing, and we're demanding that you start acknowledging that and start doing your job a little bit better, start creating more efficiencies in the workplace. So Revit. This is my icebreaker. I get everyone laughing, then we're good to go. So everyone kind of has this misconception about Revit. It's this thing, someone's sitting over in the corner, they're building a model, and while the model's being built, the building's out there on site and it's building itself. Yay, everything's all done, it's just magical. And of course, that's not true at all. So again, reinforcing that we're not talking about the tools here. That's not the conversation of VDC. We want to talk about the process, okay? Educators, I want you to take one thing back with you. You need to get everyone interested in the process, get them excited with the process. Let's develop goals. Those goals are going to influence the process so that we get to an end result. And you get your classroom excited about that, I guarantee you the tools are just going to come naturally. And that probably applies to just about anything you want to do. So modeling. Doesn't really look like a building to me, but it's a model. So what is a model? There's hundreds of different kinds of models, and we apply hundreds of different kinds of models into one collaborative environment where we actually find ourselves working and kind of making things better for the construction world. And then, of course, BIM. We already kind of touched on that. We love buzzwords. It's not really about BIM, and we're already moving away. It's no longer BIM, it's VDC. It'll be something new in a couple years. So here's some things that I always find people getting hung up on when we're talking about working in this virtual world and kind of collaboration. Where do I start? How do I begin? What do I do? What's the method to the madness? And if I was to ask anyone in here, at what level or on what level are you teaching principles of VDC or the 3D world in your construction class, I bet you each would come up with a different answer. And every answer would be absolutely legit, because I really don't think there is one single method to any of this madness, and it is madness, let me tell you. The key is that, the guys in the field, what do they need? What do they want? What are their wants and needs? Where are they going to go? What are they going to do with the information? That's what matters. What sort of project are you working on? What sort of team environment do you have? These are all the sorts of things that start to really dictate what your method is. Is there a right or wrong way to work within this virtual world? And I would say absolutely not. Again, depending on the wants and needs of your end result and the folks that you're working with, there's nothing right and there's nothing wrong about what you're doing. So don't get hung up on that. You just want to be moving forward. And does it always have to be new and inventive? And this is something that plagues my life, because I have, the board of directors always wanting to put something out there new that says we're kind of capturing our place in the market. And the reality is that nothing that I'm going to show you guys here today is really all that new or inventive, but I think to a certain degree we're taking it to new levels. We're getting more detailed, we're getting better results, and that's really important. So, never get hung up on how do we do this, am I doing it right or wrong, and certainly don't get hung up on, man, I've got to be out there doing something new and creative every time. So back to that question, what is the conversation surrounding the virtual design and construction world? Really, what I say is that it's the process that matters, okay? We're working through a process of refining information, asking all the right questions, and really getting down into the details. We want to have as much refined information out into the field as soon as possible. Forgive me, I'm going to kind of just read off slides as we go here as well. The more information, the more questions that we develop up front, the less risk we have in the long run. And we're able to deliver these packages of information out to the field. I would argue that very rarely does anyone build a construction project off of design documents anymore. Design documents are falling more into a role of intent as opposed to actually detailing out a job from start to finish. And that's no fault of the design world, it's just a reality of schedules today. And again, we have all these great new tools, but really the process and structure of design I don't think has really changed too much. Just because we can do so much more doesn't mean that we necessarily have to or want to. And then ultimately, my goal is to always create efficiencies out there in the field. So the big deal here is that the conversation around VDC, in my opinion, has nothing to do with the tools that we're utilizing. It's about that process, and the process is extremely important. So here's the proof. 20% of our energy and our time is literally spent building these models. So on a typical project, we call it 7 to 10 stories, an entire city block. We would have every engineer on a project team working 2 4-hour sessions per week for about a month and a half to develop kind of the dumb model. It's just a dumb mass. There's nothing really to it. And that's not a whole lot of time in the grand scheme of things. So that's where I say 20% of our energy is put into actually developing the model, one of our tools. Okay, so that's the proof that it's not about the tools. The other 80% of our effort and energy is put into really refining all of the information and getting that put into the models and then out to the field. So as we get design documents, we know that design documents, for the most part, produce intent, and that it's our job to now go through those documents and reproduce models, which essentially starts to highlight a lot of questions, and those are the questions that we're asking and answering before we get out into the field. So 20% involved with modeling and Revit and the tools, and another 80% that's really part of the true process to get to our end result. So Lego. Everybody has touched a Lego at some point in time in their life, and Lego represents a really great analogy that anyone can grasp in terms of what we're doing with VDC. Lego is really good at organizing, developing a set of instructions, and then providing you with one package that gets you to where you need to be. So the deal here is that it gives us an analogy to work with, and 2, it also gives you a really, really good activity to take back to the workplace or to the classroom to demonstrate lean practices and efficiencies through getting everyone organized and working in the right manner. So this is what we do all day, every day in the construction world. We take chaos. If you imagine this is a construction project where every color is a contractor, and every individual block of an individual color represents a scope of work by that contractor, you can see it's quite a mess. And that's not too far off. You take a typical project, you've got 100 contractors out there, and on average each contractor has 2 to 3 scopes of work. You now have 200 to 300 scopes of work out there. Each one of those scopes of work has its own set of shop drawings informing you how to build it. Each one of those shop drawings is, call it 20 pages. That's a whole lot of information pertaining to one project that you're expecting people to kind of decipher through out there in the field and get built. So we're going to talk a little bit about how it is we break all that down into little components and pieces to help the process gain those efficiencies. So first step is to organize all the people. Okay, we got to get everyone's teams broken out. We want to have everyone talking with one another, get them around the table. Again, we're going to take that big chaotic environment, break it down into bits and pieces, and get everyone talking with one another. This is an extremely collaborative process. And it's really just the way that we see everything going this day in construction. The next thing we want to do is organize all the parts. No longer do we have large construction sites. We have a lot of tear down and rebuild now. And the deal is that we don't have a lot of lay down space where everyone can just kind of luxuriously bring out all the materials they need, lay them down, and we can get going whenever we feel like it. The reality is that we work in more of a lean environment where we call it just-in-time deliveries. Things are arriving on trucks. Cranes are taking it off the truck. They're putting it on an exact level in crates where it's going to be built, or it's actually swung right into place on the building. So organizing the bits and the pieces and the parts is an extremely critical piece of the process. And then, of course, developing a set of instructions with pictures. Pictures being the key word there. Lego is very good at this, right? They don't give you a poster that says, this is the project and this is everything you got to do, build it, because that just doesn't work. Lego develops this process that says, here's a little component of the whole. These are the pieces that you're going to need. This is the number of pieces. This is how you put them together. This is exactly what we're doing in construction, okay? We're not looking at the whole project. We're looking at one little component of that project, and we're developing the same sort of idea for that one specific area. So back to what I was saying about, imagine 300 different shop drawings and gosh knows how many different pages, and that applies to a whole project. We don't need Beavis and Butthead out there installing, and I say that nicely because I work with these guys every day. But we don't need those guys out there in a cruise shack searching through 300 different rolls of drawings that pertain to an entire project, and all they're trying to figure out is this one little quadrant of one level. You know, we don't want those guys doing that. You know, we should be doing that, and that's what we're doing, is essentially this model right here, and that's where we're gaining our efficiencies in the field, roughly about what we find 20%. And that 20%, if you imagine 10-story building, each story is developed into 4 quadrants, so you got 40 little pieces of construction that are going on as you sequence up the building. You know, that 20% applied to each one of those starts to add up over time, and it's a good thing. And then finally, we deliver it in one kit of parts, right? Not bits and pieces coming from here and there. It's this one nicely neat packaged little piece. And I'm going to show you kind of start to finish exactly how we do that in construction. So that's the analogy. You can take that anywhere and anyone's going to get it. The activity is really great. I've seen this, I've done it myself. You can take any group of people and you can take any group of students, bring them into a classroom. You're going to go out, you're going to buy 6 Lego sets. You're going to take 3 of those, you're going to dump them into a big pile on the table, and then you're going to take a black and white photocopy of one of the boxes, and you're going to lay that there. And you're going to tell the entire group of people, I want you to get into 3 teams, and I want you each to build that. And this is great, because they kind of look at you like, you know, like, what's going on here? They kind of giggle, and then you're kind of looking at them going like, let's go, you guys, you got to do it. So about 20 minutes in, typically people are still fighting over pieces. They're still trying to figure out what their teams are, and everyone's wanting to know where the instructions are and why it is they can't have them. So that represents the old way of doing things, right? So then you stop the group, and then you break out the other 3. You hand, first of all, you take everyone, you say, get into your groups, get a table, get into separate corners of the room, get organized. Then you hand them the full package like you see here, and you ask them to build it. And of course, right away, you know, the eyes open, and it's really clear about a lean process and how to get from A to B in the right manner. So that's my Lego analogy. We've done that with quite a few different small groups. So take that back to the classroom or to your own work environment with you if you need, and I think it works great. So the bottom line is that in this virtual design world, we're bringing concrete, we're bringing steel, we're bringing curtain wall, envelope systems, we're bringing mechanical engineers, electrical engineers, plumbing, fire pipe, you name it. We've got at least 20 different folks that we're bringing to the table that we can now bring to the table all at once, because we're all walking around in the same virtual world. We're all sharing the same model and working within it. So extremely collaborative process, and lots of different personalities, lots of different agendas. So back to that idea of being organized, getting the people organized, and really finding a manner that works for that specific group. We're resolving clashes and fabrication issues in the model. So the biggest example of that is our MEP world, mechanical, electrical, plumbing. You know, thousands upon thousands of pipes, miles of pipes and conduit all coming together. Everyone's got to work together. You know, traditionally you kind of have this zone under the slab that's electrical, and then a zone of mechanical, then a zone of plumbing. But the way that buildings are becoming so technically savvy these days with their systems, those zones don't necessarily always apply. So we've got a lot of interaction, a lot of interweaving, and all of that in every project I've worked on to date all takes place in the model. And whenever something doesn't work out in the field, there's no griping out in the field. Everyone goes right back to the model and says, it worked here, why doesn't it work out there? And whoever's out of place from where they should have been in that model is the one making the change. And so it allows us to really quickly resolve issues in the field, and it's reduced issues immensely to the point of where we're actually now finding a lot of prefab, kind of multi-trade racks, where a lot of fabrication takes place in a controlled environment in the shop. This rack comes out, it's put into place underside the deck, everyone screws into it, and on this project I'm going to show you guys here in a bit, I think we have something like 2 miles of this prefabricated track that everyone was used, so all constructed in a controlled environment. Very cool. And some of that stuff is actually tested and balanced in the shop before it's brought out on site. Yeah. 20% increase in efficiencies. That's what we're seeing. We're seeing that also from some of our large partners in the MEP world and in the world of light gauge framing and steel construction. So what does all of this mean? We already kind of touched on schedules these days. The bottom line is that, you know, construction is kind of this big cycle. It goes up and down and up and down. We've all seen it in this region. And of course, those cycles are starting to get a little bit more compressed. So what that means is when kind of the economy goes down, a lot of things go up on the shelf, everyone goes into a stall mode, and then when the economy comes back up, there's projects pulled off the shelf that are ready to go, so it's a now, now, now. And then of course, there's this one little opportunity to kind of capture the marketplace for people who need space. So go, go, go again. Those schedules are tightened. And the role of a contractor in the design environment, simply because we are building before construction documents are completed, is becoming more and more prevalent in the industry. So it really, again, it's all about this collaborative process, working inside with everyone, creating efficiencies and a better product in the end. Are there any questions? That's kind of the intro piece. All right. So this is the current project that I'm on. This is down in South Lake Union on the corner of Westlake and Mercer. It's the new home for the Allen Institute for Brain Science, who are currently located over in Fremont area. And it is a 4-story below grade parking area and a 7-story above grade dedicated lab facility. So the typical floor, when you look up above the ceiling, you can't see the slab above. That's how much piping and mechanical and technology is kind of flowing in the ceilings. We have something like 10 miles of conduit in slabs. So lots of integrated pieces that are going to specific dedicated areas. Some of our goals for the project was really not to just start on what we knew and kind of stick to that, but to generate a list of what we've done in the past, really take to heart lessons learned, and then truly apply them, which I think a lot of people throughout industry, they develop lessons learned, they talk about them, but then really applying them is kind of the key part there. And then, of course, what we wanted to do was not just create little packages, little Lego packages to send out to the field. We wanted, at the end of the day, to have one comprehensive set of documents that read as a true story of construction for this project from start to finish. And that set of documents is kind of representative of each little package throughout construction on the timeline. And right now, I think I touch on this later, but right now we develop 5 sheets of details for every 1 sheet of design drawings that we have. So I think we're up at about 700 sheets. These are full-size sheets of details. So you can start to get an idea of where we start with design documents, and then really where we start to take it in terms of breaking down all the details and all the information. So some of the challenges that we had out there: extremely aggressive schedule. We had a multi-phased permitting process, and this was due to, you can see a lot of glass on this building. We needed to be in under the old energy code so that the current design worked. And so we had to break up our permitting into multiple phases, and that caused a little bit of not issues, but you know, it made it difficult. We weren't able to just have one nice, neat permit package that went in. It was broken up, and we had to kind of break construction into just the same sort of sequencing. 3 sets of grids. So for those of you that aren't aware kind of how a design gets laid out, we use grids, X, Y type coordinates, and that defines really what the building is, gives us kind of points for the columns, and just tells us, kind of gives us the baseline for dimensioning. So this project had 3 different sets of grids. Not a single set of grid was parallel or perpendicular to one another. We had design angles of like 24.36 and 129.87, which in reality, I mean, there's no tolerance out in the field that conforms to that, and you really just don't do that. So it's kind of funny to us that that was occurring, but it brought about a lot of challenge for us. There was a historic component. There was the old Ford McKay and Ford dealership that was down there at the corner of Westlake and Mercer. So that project, or that building, when they moved or widened Mercer Street, they actually took that building, put it like several thousand pieces of terracotta, moved it into a few hundred different crates, and packed it away in a warehouse. This was about 6-7 years ago. And so it's been sitting in a warehouse in crates waiting for this day to get rebuilt in a new location about 60 feet north after they widened Mercer. So that's part of the project. And then one of the bigger challenges, and it pertains to this world of VDC, is faking it. the paper documents don't always represent what the models represent. And what you have to remember, this is no fault of anyone, but the design industry develops a model for one purpose and one purpose only, and that is to produce a two-dimensional set of paper documents, okay? That's what they're hired to do. That's what their models represent. So from a coordination and construction sequencing point of view, you can't trust a design model to get you there because that's not why it was developed. That wasn't the process that they went through. That's why we're taking paper documents and redeveloping and creating new models that are actually used for the coordination and building of these projects. So really quick, I'm not going to spend a lot of time here, but I want to demonstrate. What you're going to see here is that I'm going to go through a lot of different programs. That's just to show you the different programs we're using and some of the pieces of paper that are developed from that. And I'm going to start the process here of really from the beginning where we're developing schedules and that outline our process. We get into kind of linking the virtual world to the real world and then get into kind of our packages. So we're just going to spend a little bit of time here just to show you. These right here are our modeling schedules that we developed that just start to break down different components and pieces of the model, who's going to be in charge of what, when they need to be done, and it's just kind of to keep us in line and in order. The reason I'm showing you this, because this is a really boring, mundane thing to stare at, and a lot of people don't deal with these Gantt charts and don't understand them, and it's such an important piece of kind of the upfront puzzle because what you set here in the beginning is what you're going to be held to clear to the end. So extremely important that these schedules are maintained and done in a, put together in a thoughtful manner. The next thing we do is we take those schedules that just kind of say how we're going to build the model, and we start applying them to the reality of the project. So we know that we're going to have certain dates and durations for construction for certain pieces of the building, and so we know that our modeling schedule has to fit into that and meet that, and essentially once we get to this point, what we discover is what we thought this perfect world of what we were going to do just essentially doesn't work. So then it's a back and forth to kind of figure out how it is we get things working. So that's just the schedule piece. So this is kind of a neat piece of technology. Coordinates. Coordinate points are how we link the virtual world to the world out there that's real. Okay, how it is that we take a model that's living in the computer and we link it to actual place out on site. And that's done through coordinates. And I'll show you this really quick. Oh, no, we're not going to do that. This right here is kind of our checklist. This outlines, you can see all the various bits, pieces, people involved that we check off and have to coordinate with just to get coordinates right and linking virtual model out to the site. I don't want to spend time going through it, but it kind of demonstrates all the bits and pieces that go into that. This right here kind of represents the process of how it is we link a model to the real world. So here you can see we have our grids, and you kind of see these red lines out here that represent site control. So there's a survey crew that essentially goes out and they set site control out on the site, and that goes back to a property line, and that's how the survey crews kind of align themselves to the site. Okay? In the model world, we have grids that align our building, and then those grids are dimensioned to our property lines. So that's how we link kind of everything together. The survey crew links site control to property line. I'm linking grid control to property line, and that's how we marry the two together. And so these coordinate points, I'm going to zoom in here. You can see this right here. So that's a coordinate point. That's right there at that little intersection. Gives us a northing, easting, essentially an XYZ coordinate in real time. And essentially we just kind of work back and forth, myself and the survey crew, until we've got it right and all the back checks are 100%. And essentially what we're doing is we're taking that model in the virtual world and we're moving it exactly where it needs to be so that it links back and forth to the site. It's extremely important because nowadays, and especially on a project like this where there are lots of curves, there's no 90-degree corners, everything that's laid out for construction is coming out of a coordinate point that's generated in the model. Okay, extremely important to understand. It's all done in the model. That's layout for a job like this. And with success, no issues. So I'll just quickly we'll go through. You can see here we're generating, here's the 3 different sets of grids, sorry. And every grid intersection where typically you're going to have a column, we have a coordinate point. So that gives us our grid control out on the building. And I'm going to talk a little bit about kind of the dumb point coordinate of today and where it's going tomorrow. We'll do that in just a second. Just some other helpful, this right here, these are all of our point coordinates for the project. So you can see, I mean, I think we're up to like 30,000 right now. So every piece of steel endpoint, every elevation, every corner intersection, every juke, every jag of every piece of concrete, everything has a coordinate point associated to it, generated in the model, given to the survey crew that they go out there and pinpoint. And that's how we're laying everything out. This right here just kind of demonstrates, these are all of our slab on grade. So this is an extremely useful tool right here where we're kind of showing where our slab on grade is, where our foundations for tower cranes are, and you can see here we start to link the model back to the schedule, informing us of when dates are. And this right here kind of represents all the different pours throughout. You know, I was talking earlier about quadrants, how you don't go out and you just build a level, you break the levels into different pieces, so each color represents a different piece of the puzzle in a different sequence and time. So I was saying about this coordinate point. So right now the coordinate point is kind of this dumb thing. It literally tells us X, Y, Z, and maybe you can name it. So the coordinate point of tomorrow, and this is coming from Autodesk where they see this thing, is that if you have a coordinate point sitting on a grid intersection, that coordinate point is actually absorbing all the information of modeled components. So when I send that coordinate point out to the field, it doesn't just say X, Y, Z. It says X, Y, Z. It says grid intersection A1. It says that it's sitting at column number 4, which is column type B3, which is concrete strength, 10,000 PSI. So it's literally absorbing all information from the model that it's associated with, and that information is now transferring out to the field through the coordinate point. So an extremely useful piece of technology that we've seen in our industry, in our practice, really become useful over the past year. Now utilized on all of our jobs, big and small. Yeah, it's scalable across the board for us. So these are the coordinate work packages, so coordinated work packages. This gets back to that idea of the whole Lego analogy, and this is really what it is that we're doing, and why I try to emphasize it's not about tools, it's about a process. That process is developed from goals with an end result, and that end result is to really help the guys in the field create efficiencies and stay focused on what it is they need to stay focused on. So again, imagine 100 different contractors on a job, 200 to 300 different scopes of work. Each one of those 200 to 300 scopes of work has a different shop drawing, 20 to 30 pages long. We don't need folks in the field wasting their time trying to decipher that information while they're working on this one area. So this is our process of breaking that stuff down and making it easier for the field. Obviously we create efficiencies, we create less impact, and that in itself is kind of part of the whole sustainability mission there at GLY. So again, this is just a checklist, and I'm just showing you this because it kind of demonstrates all the bits and parts and pieces that go into developing one package, one little Lego package. Okay, these are all the things that we go through, and we go through that for every single one of these little pores that make up the entire building. So let's look at a typical field package. Typical field package starts with, this is level 1. This is, we call it the podium level. This is where we meet grade. So we're transferring out of the garage and we're starting to go above grade into the building itself. Extremely complex part of the project because typically you have a set of columns down in the garage that work for parking that don't really work for the design of the building above. So you have huge beams that are allowing all your loads to shift from one set of columns to the next. So each level kind of starts off with a package that outlines what are the different pores. That's just clearly outlined by color, calls out kind of what the pore is, where it is in the sequence, and then we'll have any kind of big overlying kind of detailed sheets that pertain to the entire level. This particular sheet is dealing with a lot of civil type, how is it that the construction is going to align to the property line, to the sidewalks, to make sure the city's okay with everything. This is looking at all the various columns. You can see again we have coordinate points We do one on each side of the column because our survey crews will get out there. There'll be some stack of material or a piece of equipment in the way and they're not able to shoot it, but they can move right around the corner and use another coordinate. And we don't do this on every level because those columns will follow themselves all the way through, so they're able to transfer this up the building as they go. This right here, this is an extremely complex concrete project, by the way. This is, oh gosh, call it 100 feet off of the lake. I believe it's the closest construction that's occurred down in South Lake Union of this size recently. And so a lot of concern about what sort of soils we were going to find in there when we excavated. Very soupy, very marshy. And so what the structural design team said was, we can't do this out of steel. The steel doesn't have the weight that we need to keep the building put in place during a seismic event. So the building is all concrete, and that provides the weight to keep the building seated. And during construction and excavation, we had some 20 different deep depressurization wells that are taking the water table down and relieving the pressure around the site so that we don't have water pouring in. And we had something like 15 different kind of shallow wells. What we found was that we had an upper water table and a lower aquifer that were connected vertically on the site 100 feet off of Lake Washington. So a lot of logistical planning on how it is we're going to dig down and not get swamped. And all of those pumps remained in full action clear up until we topped out with all of our concrete, and basically we had the design weight to keep the building in place. So these are just kind of little intersections, diagrams that help some of the teams understand what's going on. We had intersections at that podium level where 4 to 5 different beam depths were all coming into one intersection with structural slabs varying in elevation above. So extremely complex just in form. And then you put a bunch of PT cables and tendons. These are the members that, when you pour concrete, it wants to sag. And then you tighten the PT cables and it pops that concrete deck right up into place. And then it's locked in. So you have various cables inside the concrete stranding in every direction on top of these extremely complex forms. So again, this is where that virtual world, we're able to put it all together, take a look at it, get all the right parties around the table, and identify what's going to be an issue, what's not going to be an issue, and how do we get there with not running into any problems. So again, these are just kind of various things that are typical of the entire level. So our package starts out looking at the entire level, and then the package starts to go down to specific areas where the guys are working. This is where the value comes in, because we're taking all the information that's out there and we're putting it in one place, because we want the guys in the field doing one-stop shopping, okay? We don't want them trying to figure out questions and decipher all the information that's out there. So what's really important, and LEGO does a really good job of this as well, is that your package is consistent in form, kind of consistent in appearance, because we had some 40 different packages for concrete on this job. We don't want to vary that, how it looks, how it feels. We want the guys to know exactly what they're looking at. We want them to know that page number 1 is a 3D picture that just kind of gives you an idea of where you're going. We want them to know that page number 2 is a plan. Page number 3 is looking at the underside of the deck where all their beams are. Page number 4 is going to have details. Page number 5 is going to be a super plot of all the MEP. We want it to be consistent all the way through. So here, and by the way, feedback from the field. These guys, they've been doing it their whole lives. They know details, they know sections, they know how to build. This was the first time that a lot of them had seen kind of this 3D picture, and it's amazing that across the board, how many people were just, God, it was great to see a picture. I know how to build it, I get it, but now that I've seen this picture, the details have a whole new level of kind of meaning to them. So we heard that time and time again, even if it's just a picture, there's no information, it's really, really helpful to the team. So as I was saying, we start with a 3D view, then we get into a plan view, and in these plan views, we really start to kind of dissect kind of what is all the bits and pieces and information. Anything that you see in red is something that a crew is going to be installing into the deck before it's poured with concrete. Once we're poured with concrete, we're done. You don't want to be in there chipping things out. So again, this right here is that one-stop shopping where we've taken all information that we had stuffed in the closet somewhere and we put it into one spot for these guys to work with. So that brings a few questions. Number one, We, GLY, are directing crews out there not to build off of their shop drawings. Okay? That's pretty risky. We are directing folks not to build off of design documents. So that's pretty risky in itself. We are directing everyone out there to build off of our documents that we give them. Okay, the reason that we do that is because we believe and we've seen that it's far less risky for us to put together a coordinated package that's been signed off and vetted through various different groups. All the main contractors have signed off on these. We want everyone to work off of one coordinated piece of paper, and we want everyone to work off the same thing. We don't want everyone kind of with the blinders on, working in their own world, doing their own thing. And what we found is that this is far less risky than just turning everyone loose and having them go at it. Is there a risk to GLY and myself, our teams? Of course. But again, there's a lot of checks and balances in place, quality control, to assure that these packages are dialed in 100% before they go out to the field. So right here is the underside of a slab. You can see blue items. These are all steel plates that are going to get set into the concrete. So if you can imagine how a concrete building comes together, they build the negative of the concrete out of plywood. And that's essentially your formwork that you're pouring the concrete into. So anything that needs to be in place for work that's going to occur 6 months down the road has to happen right now, and it has to be correct. So all of these little blue items in here are essentially, those are plates that when the formwork's stripped away, you have a steel plate under there that you can weld something to. Whether it's a wall brace or it's some sort of strapping for MEP, it could be anything. We have levels on this project where there's hundreds of these embeds, as they're called, hundreds of them across the deck, and that's just GLY. There'll be a couple hundred from McKinstry Company doing mechanical. There'll be another 100 from Valley Electric. So you imagine one quadrant of one level has 400 to 500 of these in it. Coordination is paramount. You get people stacked on top of each other, and you want that to occur in the model beforehand, not out in the field. So again, really quick, I'm just going to rush through this. This is just another example. Start with a 3D picture. There's various colors in place. Those colors never vary. They represent specific things. The guys know exactly what they're looking at when they see the color. We have a plan. Here is a good example of, this was a question that came about. There was a resolution. So we've actually snipped that resolution out of the paper document, and we plugged it right in here for the field to see. Again, we don't want them to waste their time going and searching down what the answer is for something. We put it right here on the package. This is looking at the underside. Again, there you can see those blue steel plates. Red represents dimensions for those plates. And also each one of these plates gets a coordinate point. So our guys are out there just shooting lasers, figuring out where those go. Same sort of format to call out what those plates are, who they're by, what the type number is, so everyone knows exactly what they're doing. This sort of documentation here also pertains to a crate that's flown out and put right in place. That crate contains every single one of these plates that they need, and each crate is specific to an embed type. So again, it's that idea of pre-planning. Everything's put together in a crate, it's pre-packaged, it's flown right to where it needs to be, and it's done, it's ready to go. And that's all done the night before. They build these things out one day, and then they remove the crate and they start over and start applying everything to the next sequence. So everything's pre-thought out, everything's ready to go when the crews show up. This right here is kind of interesting. This right here is a super plot of our mechanical and electrical on this slab. Each one of these lines represents a piece of conduit that is within the slab. So you can tell, I think I said something like we had like 10 miles of conduit within slabs on the project, and this is where all that comes from. Every single pour has this. What we do is we place this on here, and we get a review, cursory review, before we go to the field that says, hey, you know, right here I've got this little conduit, and it's going right through your embed plates. Is that an issue? Okay, we'll look at it. We also get to see whether or not one of the other contractors' plates are in line or overlapping with ours, and kind of distinguish, you know, who's going to have priority. And again, we're fixing things before we get out there. This right here is interesting. We're going to touch on this here in a little bit. This, once we form a deck up and we're getting ready to pour concrete, we send our survey crews out there to snap coordinates. They're now generating coordinates in the field based on that deck. And then we're taking those coordinate points from the survey crew and we're putting them back into the model. Okay, so now we have these coordinate points that out there in the real world are kind of doing this, and we're applying a variance report against the model, which is obviously this perfect, unrealistic thing. But what it tells us is the formwork out there, you can see here, green is good, is right on. It's within tolerance. But over here in this blue area, that's we're 0.064 feet. You know, that's how off they are. That right there, red is high, blue is low. And so our formwork guys actually go out there, and all the formwork's held up by these kind of big stanchions. They go out there with a hammer and they beat on them, and it just turns them, and it just kind of ratchets it up or it ratchets it down, and they'll get them all in line. So this right here is that coordinate point process working in reverse, where the field is informing the model is then informing the field, and we're getting ourselves as close to tolerances as we possibly can. So that's horizontal work packages. Next thing we do is we work on vertical work packages. We're not going to touch this first thing again. It's just a list that kind of shows you what it is, how many people are involved. But a vertical work package is simply basically our shear walls. A shear wall is a concrete wall that essentially goes from all the way down at the base of the footing clear through the top of the building, and is essentially a structural member that's providing lateral support back and forth throughout the building. And in a design model, that piece of concrete wall starts at the bottom and it goes all the way through the model as one piece. Now, never in the history of construction has anyone gone out there and formed 200-foot tall pieces of formwork and poured it all full of concrete, okay? In reality, each level is its own pour, and each level of that pour is more than likely broken into a couple of different pieces depending on what piece of that shear wall is tying into what. So again, we're taking the design model that shows the overall idea, and we're breaking it into, you can kind of see there's little gaps in here. These gaps in between these walls are the slabs. And we're breaking it into components and pieces. Okay, let's see, let's grab one of these. This right here represents one pour. Okay, again, we start with the real pretty picture. There's no information there, but it kind of informs the guys what's going on. We then have plans that kind of give the overall dimensions. And then we have elevations. This lift 2, so that's the second lift in that shear wall. Then there'll be lift 3, lift 4, and they continue up the building as we go. And what's really cool about this is, first and foremost, we're taking the architect's idea, we're taking the structural engineer's idea, we're putting it in one place and saying, yes, it all works, or no, we got a discrepancy, let's figure it out. And then we take this drawing and we ship it off to our yard, which is off-site. This is GLY's construction yard. And we have crews over there pre-assembling all of the formwork based on this drawing. And all that formwork is coming out on site the day of. It's flown right into place, built by the crews, poured, and then removed the very next day, back to the yard, disassembled. They go on to the next pour. They're reassembling, they're shipping it out. So none of this kind of formwork, kind of pre-activity is occurring out on site, taking up space, taking up time. It's all occurring off-site, being flown right in, drove in, and then flown into place. So that's vertical work packages. That's a lot of concrete, right? We do horizontal decks, and then we kind of do vertical pieces for support, do the horizontal, vertical, and just work our way up the building like that. Every single quadrant of horizontal deck or every single pour of vertical shear wall gets its own coordinated sheet that informs everyone, and again, everyone's working off of one document. So specialty packages, this is actually kind of cool. So, you know, we get done with concrete, now we're kind of working our way through the building, and we're working on all the little finite areas of the project, high-end finishes, or kind of, I guess what you might call a little tricked out space. This right here is our Seattle City Light vault. And anyone who's ever worked on a construction project and had to work with Seattle City Light, you know that they have a very specific way of what they want to do and how they want to see it, and no one ever gets it right. So again, organizing all the people, having to sit down and finding out what it is our goals are, what the process is going to be to get there, and then working in that direction. So these are actually the drawings that were submitted to Seattle City Light. We didn't submit the electrical engineer's drawings, we didn't submit the structural engineers, we submitted our GLY coordination drawings, and this is all pre-approved and worked through with Seattle City Light in the upfront process. But this right here, this represents our vault. No one location on any document included all of this information. What were the slopes in the vault that led us down to all the little drain pieces? These right here sorry, this is kind of mundane, but what you can see here is these openings are in walls. So we had in the Seattle City Light Vault, we had openings for mechanical that are only shown in the mechanical drawings. We had openings for electrical, those are only shown in the electrical drawings. In no one place did everything come together and kind of have this accurate picture of what was going on. And that's kind of the purpose of these drawings. We also, and that was a requirement of Seattle City Light. They kind of said, hey, you know, what are we doing here? How do we know that you guys got it down? This right here, this yellow piece. So this over here is the vault itself. And then along this pathway that's yellow, over to this location here is actually where the Seattle City Light feeders enter the building. So there's these kind of heavy-duty electrical feeders that run through this pathway, which is a 3-hour rated construction. That probably doesn't mean much to anyone, but a 3-hour rated construction is an extremely difficult thing to achieve, especially in a horizontal application. So there was a lot of work with different folks, different trades, to determine exactly what the details were for this. And there's no information in design documents for this. It just kind of outlines the pathway of where it needs to be, and then we come in, work with various parties, and actually develop kind of, here you can see that chase. You know, what does the wall look like? What does the horizontal surface look like? And really start to detail it out. So, you know, that's an example of a specialty package, the type of thing that we develop. We're going to skip on interest of time here. So again, we're developing about 5 sheets of these coordinated, detailed drawings for every 1 sheet of design document that we're given. And you know, that doesn't mean anything one way or another, but it kind of demonstrates the design teams are providing you with intent and a general direction. We're taking it kind of in that design build, kind of that world of design build to the next level to really work through the details and then again provide that efficiency. So lots of benefit from these packages, a lot of effort, but a lot of benefit in the end. So this is kind of neat. 4D modeling, so 4D being the component of time. Again, there's nothing special about this. We've been doing this for quite a long time. And what this, on this particular project, all the dedicated lab services, the penthouse on the project is intense. And I mean a lot of piping going on in this job. And so essentially, we have to do all the test and balancing at the end of the job that says, okay, we're good to go, everything works, you can open the building. So that test and balancing process became the critical path for completing the project. So that's now in the eyes of the owner, and this is their biggest concern of the entire project. Not concern, this is what they're interested in, right? So we now have to demonstrate that as a team, we know exactly what our sequence is going to be up there in the penthouse to get steel, to get all the trades done, and everything's going to work. And I'll show you this really quick. Green represents a 2-week cycle. So green pops up, that's what's coming in the next 2 weeks. Green pops up, that's the next 2 weeks. Okay? We've been doing this sort of stuff for a long time. There's nothing kind of groundbreaking about this. It does help us focus where our schedules need to be. It does help us kind of just visually understand, hey, you know, in the next 2 weeks, a crew is going to be specifically working in this area or that area. This specific model was developed for the purpose of demonstrating to the owner's lender, who is writing the checks month to month, of where they needed to be with their cash flow throughout the job. This work right here represented a large portion of a few different mechanical budgets. So being able to set the lenders down and say, yeah.
You cover code a lot of things. You check people for color blindness?
Yes. No, that's, believe it or not, I had this conversation last week. There are many different opinions on the matter.
More men are colorblind than women. So.
And I heard that something like 2 out of 10 men in middle age are colorblind. And this did come about, literally in a conversation last week, because we have certain teams utilizing too much color. Specifically, apparently, you notice all my dimensions, like things that are important were in red. Apparently, red is it's the most prolific color for color blindness. And so I was told, get the red off there, let's find a new color. What we're doing is, color works. It just, for the most part, it works. It paints a very clear picture, but limiting the amount of color is kind of the conversation of what we're having now. No, I know. No, the schedules, that Gantt chart that you saw that was all bars linked, so those things are all linked together as activities. So when you update the time or the duration of one activity, it flows through because, you've got this end date that everything's linked to. And what you never want to see is adjusting one thing and it actually flows through and then pops that end date out. And so I would say it's more of a task to reorganize the crews into overtime, into weekend work to regain the schedule. That will always happen. We'll always work to regain the schedule and go back on track immediately. But readjusting something like this, in the program itself, really all we're doing is saying we're grabbing a bunch of kind of model components and we're applying a time frame to them, and that's why they pop up at certain times. So is it a task? Yes. Is it a big deal? Not really. Yeah. So this was used to convince the owner's lenders that we had everything put together, and it showed the amount of work in any given area, how much work was going to occur there, which they were able then to kind of like take from a visual effect and bring over to their spreadsheets and say, okay, I understand the amount of money you're asking for this month. I understand that you're working on these big portions of components and that the monies, they kind of start to, it works out. There's no big spikes or drops in how much cash flow is being exchanged each month. So this was a really great tool to kind of get everyone on the same page and feeling comfortable about the amount of money that was going to be spent in the future. So here's this, this is a fun one. This is our historic component. And what you can see down here at the bottom, this is a laser scan. And of course, in the nature of giving a presentation on technology, it wouldn't be true unless technology failed on you at least once, right? So I had this point cloud working last night and was going to show it to you and everything was going to be great, and this morning, for whatever reason, I don't know, it wouldn't pop up. So I can't explain it. Point clouds today are essentially a laser scan of millions upon millions of those little coordinate points that we've been talking about. And they literally look like photographs. You can tell here, you can kind of see color. And what they're doing now is with these laser scans is that coordinate point actually takes on an RGB property. So it's actually, it literally is almost a photograph until you zoom in so close that you start to see the little coordinate points kind of spread out. So I told you earlier, this building about 7 years ago was deconstructed. Several thousand pieces of terracotta were all put down into crates, a few hundred crates sitting in a warehouse, and we now got to put it all back together. And we're kind of sitting there scratching our heads going, man, there is no way to do this that we're going to feel comfortable with. Because step one was to develop a brand new, shown in yellow up here, concrete backer wall that all the terracotta was going to apply to. And there's absolutely zero slack dimension in this because the terracotta is what it is. We can adjust a grout joint here and there, but if we adjust a grout joint here, it's going to flow in every direction. So zero tolerance. So what we did here was we only had essentially this point cloud to work with, and no one had worked with one before, and there are these really cool things that everyone loves to talk about, but you look at it and you go, well, what do I do with that, and really, how real is it? So what we did was we took 3 teams. This right here is Pioneer Masonry. They're the contractor that took the building down and the one that was putting it back up. These are their as-builts. So probably extremely accurate, but hard to kind of get a good, warm, fuzzy feeling off of 7 years later, someone out there with a pencil scribing down some numbers, okay? And really, we're setting this concrete backer wall like 6 months in advance, so we don't want to screw it up. So we had that to work with in addition to working with that point cloud. So what we did was we said, Pioneer Masonry, you go work in a vacuum, don't talk to anyone. We want you to back check all the work that you got going on out there, and we want you to tell us how comfortable you are with the dimensions you're coming up with. I myself worked in a vacuum, working with the point cloud, kind of working back and forth with the historic architect, looking at dimensions that we found in the point cloud and then comparing those to dimensions that we were pulling off of the terracotta in the warehouse. And then we asked the owner's survey crew to kind of take all the information possible and back check some dimensions with the point cloud and these sort of sketches. And what we're going to do is at the end of the day, we're all going to come together and we're going to compare notes on very specific dimensions that we all were working with. And we're going to see really how far off we were. And this was nerve-wracking, let me tell you, because you never know. And what we came up with was we were all about, at the worst case, a ½ inch off from one another. So I never would have thought that was the way it was going to work out. But what that told us was that, this here being the point cloud, that we were able to trust what the point cloud was telling us. Here you can kind of see it's like a photograph. You zoom in, you can actually see the little coordinate points. So we have this point cloud actually in our model, in our coordination model. And you can see these red lines here, not using red anymore. These are our control dimensions of major components of essentially where a concrete backer wall is going to come across and then step up in this location. These are the things that we wanted to back check with one another. And here you can see we're actually down there in the warehouse looking at pieces of terracotta. Again, absolutely no slack dimension. All of this was down to literally a 1/16 of an inch. We needed it all to work. Did it work 100% correct everywhere? No. We had areas where we had to come in and make some things happen. But I would say overall it was a great process and very successful. And we never would have been able to do this without technology that we had in place at the time. Okay, this is a really neat one. We'll end here. So this was one that actually turned out to be, unbeknownst to me, kind of groundbreaking and something new. So told you a little bit about the excavation, proximity to Lake Washington, the amount of depressurization, dewatering wells we had around the site. That was to keep all the saturation out of the excavation, okay, because we're digging a big hole there. I think it was about 60 feet deep, an entire city block. What we discovered was, number one, just repeating myself again, we had the upper water table and the lower aquifer vertically connected on our site. What we discovered is that we'd get the excavation down to a certain point, and we'd come in the next morning, and they're really beautiful, they're really cool, these little mineral spring wells that were springing up at the bottom of the excavation. Now, this is not a good thing, right? You want to see a contractor start sweating. So we're looking at these and we're like, wow, man, we better get the geotech out here and really have this guy look at this because they're pretty cool looking, but we don't like that. Our biggest concern was, as we dig down, we're reinforcing the walls around the excavation, right? This is the control walls, the shoring that's keeping kind of the site around us in place while we dig down. So what we started to get curious about is, well, if we've got mineral springs or we've got water activity bubbling up, there's something going on the surface of the walls, behind these walls. What does that look like? Well, you don't really know, right? There's water kind of seeping in everywhere, not something like you'd see in the movies, but there's drips coming in. That's normal, so it doesn't really kind of make you concerned. So what we did was we went out there, and you can see up above, here, I'll go over here. We had our survey crew. Each one of these, you can see these blue squares, that again is a coordinate point that the survey crew went out there and shot vertically along the steel pile that's holding the shoring wall in place. So you can see these rows. Each one of those is a steel pile. And what we did was we brought that back in, and just the same as I was telling you guys we did for the structural decks in a horizontal application, we took these coordinate points and we did a variance of these coordinate points against the perfect vertical surface of the model. And what it did was it developed this graph that told us green is perfect within tolerance, blue means that the wall is it's bowing out away from the excavation, and red is where the wall was bowing into the excavation. Or you might say there's some water activity there, right? There's something forcing that wall, there's some sort of pressure being created. So as we sat down weekly to review these sorts of conditions with the mineral springs popping up with the owner, graphs like this became extremely important in dictating, number one, what was going on, where it was going on, and then also predicting where we might have another issue and where we need to just reinforce a little more. So this red line right here that you see, that right there happened to be right in front of where all those little mineral springs were. So there was a definite correlation between where those mineral springs were popping up and activity pressing up against the wall. So this was something that was kind of neat. It just made sense, you know, if we can apply this sort of process and technology in a horizontal application, why can't we apply it vertically? So we actually got a phone call from Autodesk, the manufacturer of the software. They're up there with a Microsoft, and said, what is that you're doing? We don't understand. And we walked them through it and talked about how we did it. And we're talking to programmers, right, not construction folks. And the programmer says, I understand, yeah, it would work from a programming point of view, but they had never seen this application before, and so that's something that they're really excited about. And then, of course, we got a little excited, too, because it was something new and inventive. You know, we're able to give something to the powers that be and say, here you go. And so, really quick, I'm getting the eye. Conclusion, technology is not going to go away, all right? It's only going to continue to advance. It's only going to demand that we do our jobs better. We're only going to have better tools to work with. Don't just copy what's already been done, you know? Use that as your foundation and then move forward. Blow it out of the water. That's kind of the motto of what we're doing. The contractor's role in assisting the design team is not going away, so we want to make sure that we're working in a correct and collaborative manner and not getting too full of ourselves. And again, you guys, it's not about the tools. That's not the conversation. It's about the process. Get everyone involved in the process. The goal is the end result, and the tools will come. That's my information if you ever want to get in contact with me or have this presentation in the classroom. Thank you.